okay? So proofs about perpendicular lines and parallel lines. I think today's homework's relatively short. Today's notes is pretty short. It's just a couple of proofs. So we have a few theorems to talk about. The first theorem that we are going to talk about is called the linear pair perpendicular theorem. Linear pair perpendicular. It basically means when you have a linear pair that ends up being perpendicular. Okay, so context clues with something like that. It says if two lines intersect to form a pair of congruent angles, then the lines are perpendicular. So if two lines intersect to form a pair of congruent angles, then the lines are perpendicular. So in this picture here, you have line G intersecting with H. If I told you angles 1 and 2 were congruent, what kind of angles would they have to be if they're congruent? 90 degrees, right? They would have to each be 90 degrees. That's the only way they could both be congruent. And if they're both 90 degrees, what kind of angles are 90 degrees? Right angles. So if these are both right angles, then you have a linear pair that ends up forming perpendicular lines. That's basically what that means. Because I didn't want it to be too obvious in the picture. Yeah, so basically what this means is if angle 1 is congruent to angle 2, then line G is perpendicular to line H, right? Because you'll have a linear pair and they both are 90, so it's perpendicular. The next one is the perpendicular transversal theorem. This says if a transversal is perpendicular to one of two parallel lines, remember that's a parallel symbol, not an 11, then it is perpendicular to the other line. So if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. In other words, if you have two parallel lines and there's a line going through them and it's perpendicular to one, it has to be perpendicular to the other. The reason that happens is because this is actually an angle relationship. If you box these corners, isn't that your F shape? Those would be corresponding angles. And if you have parallel lines, your corresponding angles are congruent. If one of them's a right angle, the other one also has to be a right angle. So basically, if it's perpendicular to one, it has to be perpendicular to the other. So what we would say is if line J is perpendicular to line H, and line H is parallel to K, then you can say line J is perpendicular to line K. And this is my weird like cursive J, that's what that is. So if line J is perpendicular to H and line H is parallel to K, then line J is perpendicular to K. So if it's perpendicular to one parallel line, it has to be perpendicular to the other one. And then the last theorem is lines perpendicular to a transversal theorem. This is just kind of like the opposite of that. If lines are perpendicular to the same line, then they are parallel to each other. So this is the opposite. If you have two lines and they're both perpendicular to P, then they have to be parallel to each other. Because again, if you outline this, if you box in these corners, isn't that your F shape again? So you have congruent corresponding angles. If those two angles are congruent, then your lines are going to have to be parallel. So that's how that one works. I would, really the main thing to remember about this is if you have parallel lines, you're going to have either congruent or supplementary angles. So I would maybe make a note to yourself here, because this is like the main thing with this section, is that parallel lines give you congruent or supplementary angles. Okay. I think I said it before, but I say it a lot. Parallel lines are good for only one thing, and that is giving you congruent or supplementary angle relationships. It's their only purpose for things like this. So if you have parallel lines, you're looking for maybe a pair of congruent corresponding angles, congruent alternate interior angles, congruent alternate exterior angles, or same side angles that are supplementary. So those are really the only things it's the only purpose of it, really. So all we're going to do now is do 3 proofs and then we're done. Okay, so it shouldn't be too bad. This first proof, we are given that line H is parallel to K. You'll notice the little triangles in there. Remember, that means they're parallel. And that line J is perpendicular to K, or to line J is perpendicular to H. We're going to prove that if it's perpendicular to H, it's also perpendicular to K. Now, if you've been paying attention, you might be like, well, yeah, that's one of the theorems we just did. It's this theorem, right? If it's perpendicular to one, doesn't it have to be perpendicular to the other? We know that. What we're doing is actually proving that theorem. We're proving why that theorem works, okay? So in the future, you can just say, oh, perpendicular transversal theorem. But right now, we're proving why that's a thing, why it's okay to do this. So first of all, always make sure your picture's labeled. This one was for us. Our parallel lines are marked and our perpendicular lines are marked as well. We are going to prove that we also have perpendicular lines here. Now let's think about how you would do that. Perpendicular lines make what kind of angles? Right angles. So if I can prove that either angle 5, 6, 7, or 8 is a right angle, won't I know those are perpendicular? Yeah. Does it matter which one you prove? No. Any of the 4. It does not matter. Now, what I would probably do is look for an angle relationship. Again, I gave you parallel lines, find an angle relationship. Does anyone notice an angle relationship that happens with 2 and another angle in this picture? Think corresponding, alternate interior, alternate exterior, or same side interior. There's more than one correct answer. Andrew, you think you know? 2 and 6 are corresponding, absolutely. 2 and 6 are definitely going to be corresponding, right? You have your F shape. So if these lines are parallel, won't 2 and 6 have to be congruent? So won't 6 have to be a right angle? So won't my lines be perpendicular? That's the proof. We just now got to write it down. Okay? So first thing is always what? What do we say first? Given. You do not want to know how many Chapter 2 tests I graded that did not have given as the first thing. That is a free half of a point. Please, please, please. The first thing is always given. Okay? And your first statement is already written for you. Just type it in if it's not there. It's the exact same thing. Okay, so that is given. Then we're going to say that angle 2 is a what? Well, vocab. Think about your vocab. In your given, weren't we told that we have perpendicular lines? Perpendicular lines make what kind of angles, guys? Right angles. So I can say that angle 2 is what kind of angle? A right angle. Angle 2 is a right angle. What's an appropriate reason for that? What vocab word did I just use? perpendicular, right? If I give you a vocab word, use it. So that is the definition of perpendicular lines. Okay. Now, I could then say, oh, it's 90 degrees, great. I don't need to though. Because if I can show I have two right angles, aren't all right angles going to be congruent? That's a theorem we actually learned before. So what we're going to do now is say what angle relationship we had. Angle 2 and blank are blank. Now I left this all blank for you because there was more than one good answer. Andrew told us that 2 and 6 were corresponding angles, so that's what we'll go with. Angle 2 and angle 6 are corresponding. Ooh, my handwriting is getting very poor. I have to zoom in. I'm zooming in. Just look at the picture on your diagram if you need it, because it just is so much easier to write on this if I'm zoomed in. So angle 2 and 6 are corresponding. How do we know that? What did we look at? We looked at the picture. So that is given by the picture. All right. Now it wants me to say that two things are congruent. Use your context clues. What are the only two things we've even mentioned in this proof yet that we could say were congruent? Angles 2 and 6. Angle 2 would be congruent to angle 6. And we know we could do that because they were what kind of angles? Corresponding. So then we say the corresponding angle postulate. And if you accidentally write theorem, that's not the end of the world. Okay, no big deal. And then we're actually almost done. We got one more thing. If angle 2 is a right angle and angle 2 is congruent to angle 6, what could I then say about angle 6? Think about it. If angle 2 is a right angle and 2 and 6 are congruent, what can I then imply about angle 6? It's a right angle. So let's say that angle 6 is a right angle. And if angle 6 is a right angle, will those lines be perpendicular? Yeah, that's exactly where we wanted to go. Now the reason, why can I say this? Well, 2 and 6 were congruent, right? 2 is a right angle, so we can imply 6 is a right angle. That's technically called the right angle congruence theorem, but most people don't remember that. We can just say all right angles are congruent, because that's easier to remember, because aren't they all 90 degrees? So they're all going to be congruent. Okay. And then last step, we have a right angle. Right angles imply that I will have perpendicular lines, right? Now think about that. Do you think that'd be the definition of a right angle or the definition of perpendicular lines? So we'll think about what a right angle is. If an angle is a right angle, that means it what? Has a measure of 90 degrees. But did I say anything about 90 degrees? No. So we probably don't want to use definition of a right angle. Instead, Tyler? We're actually proving that, so we wouldn't want, that's like using the word in the definition, you know? So what we would actually just say is the definition of perpendicular lines, because if you have perpendicular lines, then they make right angles. So yeah, we would say the definition of perpendicular lines. We only use the definition of right angles if we're trying to show something's 90. How did my squiggle end up all the way down there? What happened? Did it just like magically move itself? Did it? That's so weird. Okay. Sure, Gannon. Absolutely, yes. So you could absolutely also do this by saying that 2 and 6 are alternate exterior angles. Yeah, was that your question? Yeah, totally. You could do that. And if you were given a, angle 3 instead, you could have done like 3 and 6 are alternate interiors. There's a lot of different ways to do it. So yeah, if you were doing it on your own, I would accept a variety of different things, Gannon. All right, next one. Oh, why is my picture up here? Is your picture messed up? No, your picture's in the right place. It's just on mine. I'm just lucky like that. Well, no, but like I didn't know if it was in the right spot. Isn't this where it should be? Okay. Mine moved. As long as yours is in the right spot, that's what matters. I can move mine. Okay. So now what we're gonna do, we've seen this picture before, haven't we? We saw that up in our first theorem here. We're gonna prove our first theorem. So we're gonna prove the linear pair perpendicular theorem. So we're gonna explain why it works. So we are given that angles 1 and 2 are a linear pair and that angle 1 is congruent to 2. We want to prove that since these are a linear pair and congruent, G will have to be perpendicular to H. So we're going to explain why that works. Now we kind of talked about why that worked when we talked about the theorem, right? If they're both congruent, won't they both have to be 90 degrees? And if they're 90 degrees, then they'll be right angles and then the lines will be perpendicular. Oh no, I lost my connection on my MacBook. Oh, lovely. Okay, so that's basically what we need to do. We just gotta write it in proof form. So let's look at our context clues here. First thing is always what? Given. Should you ever get that wrong? Is it ever gonna change? Free half a point, guys, that is given. All right, people at home, you can still hear me, right? Okay, my MacBook disconnected, so I just was making sure. Okay, so angles 1 and 2 are a linear pair and angles 1 and 2 are congruent. Now, use your context clues, use your vocab. Do I give you guys a vocab word in the given? What vocab word is in your given? Linear pair. If I give you a vocab word, should you use it? Yes. Should you kind of always have that chapter 2 vocab sheet handy? Yeah, probably. Okay. So does anyone remember what a linear pair is going to give you? What kind of angles do linear pairs make? Anybody? Anybody? Linear pairs? They're supplementary. Yep. If you have a linear pair, we can say that angles 1 and 2 are supplementary. Very good. And again, use your context clues. You were given a linear pair, right? So then the appropriate reason for that would be the linear pair theorem. And if you have to use that on a test, it's very likely to be like a drop-down box thing, right? So I gave you a linear pair, so you used a linear pair. Now look at line 2. Do I have a new vocab word? What's my vocab word in line 2? Supplementary. If I give you a vocab word, you should probably use it. What does it mean for two angles to be supplementary? They had to be 180. Oh, why did it do that again? It like scrolled with me. I hate this computer so much. Bless you. And look, now there's like weird little boxes all over. What is happening? Guys, send help. What is this? What is happening? Let's see. There we go. It's back. Maybe. Okay. We're sort of doing things. There we go. It was upset at me. It doesn't like doing proofs. Okay. So, yes, supplementary angles do add up to be 180 degrees. And if you look at line 3, would that be a logical next step anyway? Because I'm giving you the blanks. What should I fill in these blanks? Right, good. The measure of angle 1. Oh, and now the pen turned off. Awesome. The measure of angle 1 plus the measure of angle 2. Use those context clues, right? I gave you the vocab word supplementary, so what do you think an appropriate reason would be? Definition of supplementary. Yep. Definition of supplementary angles. All right, now I'm giving you the hint to use the definition of congruence. Do you guys remember what the definition of congruence lets you switch between? It lets you switch between two things. Tyler? Very good. Yes, the congruent symbol and then the equal sign. And if you look at step 3, you might be like, well, how am I supposed to do that? I didn't say anything was congruent in step 3. But didn't you say something was congruent in your given? And if angles 1 and 2 are congruent, are they also equal? Definitely. So we're going to say that the measure of angle 1 equals the measure of angle 2. Now, the reason we're doing this is because we want to show just one of our angles ends up being 90 degrees. So in order to take an equation and show that just one ends up being 90 degrees, aren't we at some point going to have to take 180 and divide it by 2? That's the only way I can think of to get 90 at least. So what we're going to need to do now is it's telling me to substitute. Well, what could I substitute? I have an equation, and I know that the measure of angle 1 and the measure of angle 2 are the same. And when things are the same, aren't they interchangeable? Yes, no, maybe. When things are the same, are they interchangeable? Yeah, so what I'm actually going to do here is a little bit of, I'm going to switch some things up. I'm going to, instead of saying the measure of angle 2, I'm going to replace that with the measure of angle 1. Because if things are equal, I can interchange them. So what I'm then going to say is that the measure of angle 1 plus the measure of angle 1 equals 180. I substituted 1 in for 2. Now why would I want to say that? What would be the point of that? Well, adding something to itself is the same thing as doing what? Multiplying by 2. So couldn't I also write this as 2 times the measure of angle 1? Wouldn't that mean the same thing? Yeah, that's also substitution. Now again, why in the world would I want to do that? Well, if I'm multiplying by 2, can't I divide by 2? And what's 180 divided by 2? 90. Why would a 90-degree angle maybe be helpful if I'm trying to show things are perpendicular? Yeah, you have to have a 90-degree angle for it to be perpendicular. Now, this proof's tricky if you're like, oh my God, what's happening right now? This isn't one I would expect you to write on your own, okay? But this is using some different context clues. So we're going to divide both sides by 2 to get that the measure of angle 1 equals 90. That is the division property because I divided on both sides. Now we're almost done. If angle 1 is a 90-degree angle, what kind of angle is that? What is the name we use for 90-degree angles? Right angle. So we're going to say angle 1 is a right angle. That would be the definition of a right angle, because right angles are 90 degrees. And why do we want that? Well, right angles make what kind of lines? Perpendicular. So we're going to then say, what are the names of my lines again? G and H. We're going to then say that line G is perpendicular to line H by the definition of perpendicular. Ooh, except I can't spell Perpendicular. We don't want to use the definition of a right angle again because that has to deal with 90 degrees and we're already past that. All right. Last one. And then we'll get done nice and early and you guys will have lots of time to work on your assignment. And it'll be your last assignment. So last one. Here we are given that angles 1 and 2 are a linear pair. Angle 1 is congruent to angle 2, and these lines are parallel. I'm giving you a bunch of stuff. So angles 1 and 2, oh, and it's a short one. How nice of me. I must have been, I don't know, in a good mood when I made this one. So angles 1 and 2 are a linear pair. They're congruent. Let's mark that. They're congruent. And we have parallel lines here. Okay. We are trying to prove that segment BC is perpendicular to line B is perpendicular to C. So I want a right angle here. Okay, so I pretty much need to prove that angle 3 is a right angle, right? If those are going to be perpendicular. So this looks an awful lot like this theorem, doesn't it? If it's perpendicular to one line, or I'm sorry, if one line is perpendicular to it, the other line will be perpendicular to it as well. That's actually the theorem we're going to use here, except I have a problem. Was I told that angle 1 or angle 2 was a right angle? No. But if I can show 1 or 2 is a right angle, can I then show that 3 is a right angle? Definitely. So do I have enough information to say that 1 or 2 is a right angle? I definitely do, because if you take a look, aren't 1 and 2 a linear pair? Aren't they congruent? So what kind of an angle are they going to have to be? A right angle. Does it matter which one I say? Not really. So I'm going to say that angle 2 is a right angle. That's actually our new theorem that we just proved right above. They were a linear pair. They were congruent. That is the, what's it called? Linear pair perpendicular theorem. Oh, I forgot to write given. Thank you. Yeah, yeah, gotta have that half point. And then this is the linear pair perpendicular theorem. Right? They're a linear pair, they're congruent, so it's perpendicular. Now I have that angle 2 is a right angle, or angle 1 if you would prefer. So if angle 2 is a right angle, and line A is perpendicular to, or is parallel to line B, what do you think I can then say about angle 3? It's a right angle. We actually kind of need another, oh wait, no, we don't need another step because this is another one of our theorems. If you go up, oh my God, it moved. Look, it did it again. It's gonna be it's like haunting me. If you look up here, if two lines are perpendicular to the same line, or no, wrong one, this one. If a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other one. So I actually have enough here because aren't these two lines parallel? Isn't it perpendicular to one? So won't it have to be perpendicular to the other? Yeah, that's actually just our theorem. Now, could you do this in more steps? Sure, like you could then say that's a right angle, right angles are congruent. You could do a bunch of things with that, but you don't have to. We can just automatically then, if angle 1 is a right angle, then, oh wait, I know what I did wrong. Anyone know what I did wrong? I have the wrong statement written down. Go look at your linear pair perpendicular theorem. It doesn't say that you have a right angle. Not congruent. If two lines form a pair of congruent angles, then the lines are perpendicular. That's why I confused myself. I don't even need to say, again, I'm just going, it's another way to do it. There's more than one good way to do this. So I just went a different way and I didn't want to go that way. The linear pair perpendicular theorem lets us say if we have that linear pair and they're congruent, then we can say line A is perpendicular to line C. We then know that. Does that make sense now? Okay, sorry about that. Line A is going to be perpendicular to C, and if A is perpendicular to C, can we then say B is perpendicular to C? Yes, and that is our perpendicular transversal theorem. If it's perpendicular to one, then it's perpendicular to the other. And then we're done with that one. And we're done. Like 45 minutes early. You're welcome. Happy end of the quarter. You're welcome. I don't know why this still isn't working. People at home, any questions for me?